Hello friends, in this session we will discuss on sustainable development and environmental accounting. Let us start with the introduction. National income accounting or social accounting is an important concept that follows the procedure of adding different values. On the one hand, it is a flow of income accrued to different factors of production such as land labor, capital and entrepreneur who receive income for their contribution to production in the form of wages, rents, interest and profit. On the other hand, it is flow of goods and services, that is product flow. This concept is significant for categorizing different countries as developed or developing. It also shows that how the country is performing economically. This concept of national income accounting does not take into account the exertion, exploitation and depletion of natural resources. However, for the study of environmental and development issues, we must incorporate the natural resources of all types so as to know less of environmental and the extent of adverse consequences of exploiting natural resources beyond limit. Hence, the accounting of income to be developed accommodating all the resources including the use and abuse of renewable and non-renewable resources, that is all about sustainable accounting. Only with such an accounting system are the linkages between environment and development better understood. The concept of resource accounting started almost 3 decades back at the end of the development methodologies for project evaluation in the early 1970s. The procedure has been evolved gradually after identifying the gaps in the system of national accounts (S&A). S&A has one basic deficiency, that it can take note of only such production and consumption processes where there is a market price. Talking of sustainable accounting, 2 additional difficulties are to be noted. First, non-imputation of the values of environmental goods and services used in production processes, and second, absence of any allowance for depreciation, degradation or depletion of natural resources. Improvement in the methods of S&A were debated in the 1992 United Nations Conference on Environmental and Development (UNCED) held at Rio de Janeiro, which recommended all nations and the United Nations in particular to develop a system of integrated environmental and economic accounting, which is known as IEEA. What is economic accounting? The conventional system of national account (S&A) was first started in the United States of America in 1942. The starting point for such accounting is an identity all valued in market prices. Aggregate demand is equal to aggregate supply, or domestic production plus imports is equal to intermediate use in production processes plus private consumption expenditure plus public consumption expenditure plus gross investment plus export. Using the input-output transactions framework, the gross domestic product GDP is defined as GDP is equal to domestic production minus intermediate use consumption, which is equal to private consumption plus public consumption plus gross investment plus exports minus imports. For any accounting year, some further adjustments such as adjusting for changes in the stocks of goods may become necessary. The method of S&A is basically arithmetic, tracing all flows of incomes or goods and services in the economy in an accounting year. An added element to S&A is the statement on the man-made capital stocks in the economy. The accounting identity for this is closing stock is equal to initial stock plus investments during the accounting period minus capital depreciation. According to Hicks, National income accounting is providing the basic principle to define income as a welfare indicator. He allocated the inclusion of all current consumption that do not impoverish future consumptions. He also pointed out that the man-made capital is important since it contributes to national income, but its depreciation over a time, for example machine, should be subtracted from national income in order to get net nation income of product NNP. Hence, we have NDP is equal to GDP minus D, where D is a depreciation. An environmentally adjusted NNP would be conceptually expressed as follows. An environmentally adjusted NNPE would be conceptually expressed as NNPE is equal to GDP minus DM minus DN, where NNPE represents the environmentally adjusted net national income and DM is depreciation of physical capital and DN is the depreciation of natural capital assets. Integrated environmental and economic accounting. The main objective of environmental and economic accounting is to expand existing systems of national economic accounts in order to integrate environment and social dimensions in the accounting framework. Alternatively, at least satellite system of accounts for natural resources be developed to arrive at what is currently being coined as green GNP. One of the first questions to answer is, can the logic of depreciation be extended to exhaustible resources? The answer is no. The case of exhaustible resources is of course different. Extracting it now can in no way assure constancy or improved welfare in the future. In non-substituting society, therefore, the Hickesian measure of income from the extraction of an exhaustible resource is subtracting the value of all such extractions. The incomes of the countries that are heavily dependent on extractive activities, for instance, if a country's income were coming only from crude oil extractions, then it would imply that its national income would have to be treated as zero. The only solution to this puzzle was given by the modified Hartwig rule defined earlier, which suggests that along the equilibrium path, as long as the rental income from the resource is reinvested, the future income stream will remain constant. This also makes investing on capital formation and resource development legitimate expenditure towards welfare. Take the case of forest resources. Forests are part of the natural capital of a country. Can one develop an accounting for it as easily as for man-made capital? The answer is yes in theory, but difficult in practice. Number 1. The major difficulty arises from the distinction between depreciation and depletion. In the case of depreciation, it can remain as a national value judgment. The same cannot be said about natural resources when they actually degrade and deplete. Second, accounting for additions to forest stock is not easy. It takes place both through natural regeneration and plantation. For each of these, one ought to have good data and information about the survival rates. In other words, it is not as simple as accounting for capital formation in the usual national income accounting sense. Third, the flow from forest stocks is only partially accounted as legal extractions. Much of it is not. Then there are several natural phenomena such as forest fires, landslides, earthquakes, floods, etc., on account of which there are changes in this natural capital. In short, physical accounting of forest stock and flows is a complex task. Consider another example, that of air quality and environmental resource for sure. Its accounting will have to take note of the pollution added by the industries, the carbon sequestration done by the forestry sector, additional defensive and preventive investments done by individuals, and the government to prevent hazards from degrading air quality, externality costs such as medical expenses incurred by individuals due to degraded air quality, and many more. A shortcut to these actual accountings is to assume an optimal pollution abatement strategy and account for its cost. The figure given here shows an analytical method of deriving the optimum pollution level and the polluter pay price for it. MEB is the marginal benefit from abatement, whereas MEC is the marginal cost of abatement. The level of social tolerance of pollution is OW star, whose social value is OC star, to be charged as polluter pay charge. Next is the question about non-market values of natural and environmental goods and services in the accounts. This raises the question of linking valuation natural resources with income accounting. Weizmann in 1976 and Hartwig in 1990, among others, developed analytical models linking valuation of capital and other resources with income accounting. An alternative satellite accounting was developed by UN agencies known as UN 1993. Under this, alternative stock and flow changes in environmental resources be treated in a separate table, leaving the basic S&A uncharged. As far as integrated income accounting is concerned, some progress has been made at least on the empirical side. Parikh in 1992, UNDP 1993, UNEP 1993, Puskin in 1989, among many others, have suggested methods of gracing national income accounting by going back to the basic structure of the macroeconomy seen in terms of an input-output transactions table. This basis comes from Leontief 1966 and Stone 1961. The approach starts with identifying all such sectors which are environmentally and natural resource wise significant. Flows of outputs or services from those natural and environmental resources or factors used as inputs by others are to be identified. Additional columns of consumption to account for flows from natural and environmental resources directly in the form of final use are also incorporated. The modified input-output table can be used to define the adjusted value added as well as final consumption, accounting for environmental and natural resource uses. In this manner, one would have accounted for the use of natural resources both as intermediate inputs as well as final use consumption. The method is quite appealing, simple in description, but is equally complicated to implement. Economists need not be reminded about the complexities in estimating even the regular input-output tables of an economy. Parikh and Parikh 1997 have further elaborated on the system of environmental and economy accounting SEEA as developed by the United Nations. They provide a definition of Green Net National Product NNP shown in the box. Input-output based SEEA. Here, net national product is equal to value of consumption of normal goods and services plus value of production of nature collected such as fuel, wood biomass plus value of environmental amenities provided by environmental resource stocks such as clean air, topsoil, plus value of leisure enjoyed, say in enjoying aesthetic beauty of wildlife resource, plus value of net additions to production capital, plus value of net additions to natural capital stocks such as plantations in forest or depletion of exhaustible resources, plus value of additions to stock of defensive capital such as water purifier. Issues of sustainable income accounting. In relation to sustainable income accounting, there are number of issues both at the theoretical and empirical levels which can be analyzed as: number 1, the issue of defensive expenses. In sustainable income accounting, this issue needs to be carefully dealt with. These expenses are incurred by the society as precautionary expenses against facing the externality effect of environmental degradation. For example, the purchase of a water purifier to protect against deteriorating water quality. How to treat this cost incurred by the society for sustainable income accounting? How to put this within the framework of S&A? Similarly, expenses incurred to get clean air and other natural resource depletion costs have also the same problem of their entry into sustainable income accounting. However, there are two ways in which defensive expense can be considered as part of consumption expenditure. Alternatively, they can be treated as a negative regeneration, that is, substitution instead of regeneration. The alternative method of treating defensive expenses as negative regeneration with the sustainable income accounting methodology can be useful in understanding implications of public investments on environment related defensive expenses. For example, urban solid waste incineration plant. Number 2, maintaining balance in account. Income accounting is a balance between income and expenditure. It is not enough to account for externality only at the level of expenditures. There has to be a balancing account at the income or value added levels. How does one deal with income earned from working with environmental management programs? For instance, a pollution abatement program creates value added in terms of wages and profits, but from the expenditure side, it does not improve the welfare of people paying for it. This disequilibrium impasse can be resolved by assuming a full employment situation where labor deployed in pollution abatement is considered to be a transfer from normal goods production with no change in welfare and value added. Number 3, issue at the stage of estimation. As a starting point, depending on data availability, only a few of the natural resources are perhaps accountable. The question of the validity of dealing with only a select list of natural resources for accounting and integrating with the S&A when the natural resource endowments of an economy consist of many more such resources. The notable ones that are normally left are renewable resources and biodiversity. Number 4, long-term consideration. S&A is a flow income accounting system. Welfare benefits from preservation of natural resources have a long stream of benefits. In a strict theoretical sense, such benefits cannot be easily written off under current income or welfare streams. This issue gets more complicated, particularly because of the fact that preservation can be costless. But it involves sacrifice of current consumption from developmental use of natural resources. Therefore, care should be taken to spread preservation benefits over a long-term horizon. Number 5. The issue of double counting. The double counting is a very common problem in national income accounting. The same environmental services are doubly counted. For instance, timber after falling from the forest has a price reflecting its use or utility value, but it has emerged out of carbon sequestration function of the forest abating global climate change, having a non-use value. Now, how does one segregate its use and non-use values? To further complicate matters, what is to be done if the security value of forest is also to be accounted along with the timber and non-timber values? A practical approach is to treat part of the use value as additional option value or non-use value. Number 6. The issue of integrating the values of natural resources with national income accounting. This has one theoretical problem. The values of environmental resources are elicited broadly based on two methods, namely revealed preference values and stated preference values. Values derived from market prices refer to revealed preferences. Many others are based on stated preferences, non-use values or even use values for non-marketed goods and services deduced from, say, a contingent valuation method. It is here that an inconsistency can arise when all such values are to be aggregated, knowing that different valuation methods follow different pricing systems. Only some empirical norms of adding such revealed and stated preference values have been developed. Therefore, the task of bringing valuation and income accounting closer is still far from complete. On a theoretical basis, there is no guarantee of an integration of these two so as to arrive at a system of adjusted national income accounts. UN 1993. Taking all these issues into consideration, can one at least conceptually define an integrated sustainable income? The steps involved in deriving such an adjusted income measure are shown in the box. A conceptual model of integrated environmental and economic accounting. Adjusted net domestic product is equal to the usual UN definition of net domestic product minus adjustment for exhaustion of deflectable natural resources with appropriate shadow prices minus social cost of degradation of environmental quality and quantity, again in appropriate shadow prices, plus preservation benefits enjoyed by the society after deriving its annual benefit streams for which perhaps no payment is made by the society, plus employment benefit of labor employed in preservation activities valued in terms of its own opportunity cost, plus regeneration cost incurred valued in shadow prices. Environmental accounting and algebraic presentation towards environmentally adjusted national income accounts. GDP is equal to C plus IG. Consider it as equation number 1. GDP is equal to gross domestic product and IG is gross investment, where C is private and public consumption. The equation shows the expenditure flow. By subtracting depreciation on capitation from GDP, we get net national product NNP, which is equal to GDP minus DM, say as equation number 2, where DM represents value for the depreciation allowance for capital, and environmentally adjusted NNP would be conceptually expressed as NNPE is equal to GDP minus DM minus DN, let us say equation number 3, where Dn is the allowance for the depreciation of natural assets such as overfishing, deforestation, overgrazing, excessive soil erosion, etc. Environmentally adjusted sustainable national income accounting, green accounting. At the macroeconomic level, this can be interpreted as the maximum amount that can be spent by nation during the given year, while making sure that capital assets remain intact so that productivity in the future is not compromised by lack of sufficient capital. This concept of income is clearly consistent with the weak sustainability. Thus, using weak sustainability as a tool, we reinterpret identity 3 as NNPE is equal to GDP minus DM minus DN. NNPE is equal to C plus IG minus DM minus DN. Let us consider as a 3A. In summary, the two conditions for an environmentally adjusted sustainable flow of national income can be stated like this. Number 1, NNPE shown in the equation indicates the amount a given nation can produce or consume without undermining its capacity to produce the same amount in the future. Number 2, furthermore, for this condition to hold, nations are expected to reinvest their saving in such a way that their productive capacity will remain intact. The environmentally adjusted net domestic product (EDP). The 1992 Earth Summit in Rio de Janeiro declared sustainable development to be the key to integrating social, economic and environmental dimensions of development into planning and policy making. Its action plan, Agenda 21, considered combined environmental and economic accounting as a first step towards the integration of sustainability into economic management. This development led to the creation of the system of integrated environmental and economic accounting (SEEA). Its primary purpose is to provide a systematically organized set of aggregate environmental and economic information for which indicators of performance can be derived. The SEEA was revised in 2003, although without much structural change. Structurally, the SEEA comprises 4 major categories of account: flow accounts for pollution, energy and materials, environmental protection and resource expenditure accounts, natural resource asset accounts, and valuation of non-market flow and environmentally adjusted aggregates. Despite many difficulties, using SEEA database has now become common practice to measure EDP on a country-by-country basis. The EDP per capita is computed by deducting environmental cost from net domestic product and dividing it by the total population of the nature under consideration. EDP divided by P is equal to NDP minus EC divided by P, say it equation number 4, where EC and P respectively represent environmental cost and population. The environmental cost include expenditure on environmental damage controls, the depletion of exhaustible resource, and the degradation of environmental assets. Genuine savings. The concept of environmentally adjusted indicator of sustainability was developed under the sponsorship of World Bank and has been utilized by many countries as a policy guide for their sustainability initiatives. The indicator operates within the general framework of the SNA and uses environmental statistics from the satellite accounts of SEEA. The main idea behind the genuine savings as an indicator of sustainability is straightforward and it is imputed using the following formula. Genuine savings, that is GS, is equal to GDP minus C minus DM minus DN plus HE minus ED, where GDP is equal to C plus IG as defined in equation number 1. GDP minus C is equal to gross domestic investment IG. DM is equal to the depreciation of human made produced capital. DN is value of resource depletion. HE is the value of investment in human capital. ED is imputed value of environmental degradation. The Index of Sustainable Economic Welfare, ISEW. Herman Daly, an economist, and John Cobb, a theologian, conceived the basic idea of what is now known as the Index of Sustainable Economic Welfare in their book For the Common Good in 1989. The aim of this index has been to combine the economic, ecological and social aspects of human endeavors, which are often separated. Furthermore, the ISEW is used as an indicator of economic performance in the way as GDP, EDP and GS, but has the added benefit of being used as a yardstick for measuring economic well-being. How to compute ISEW? Step number 1 starts with the personal consumption expenditure, that is PCF. Step number 2, weight the PCE with an index of income inequality, that is Gini coefficient. Step number 3, estimate the rate of consumption of consumer durables by finding the difference between the cost of consumer durables and the service annually yielded by previously purchased consumer durables. Step number 4, determining the annual rate of consumption of publicly provided capital, for example, highways, schools, national park, etc. Step number 5, impute the value of the services of unpaid household labor. In summary, ISEW per capita is computed like this. ISEW divided by P is equal to alpha into PCF plus D divided by P. Here PCE is equal to personal consumption expenditure. Alpha stands for parameter of PCE to inequality. P is population. And D is the difference between the expenditure on consumer durables and service flows from consumer durables plus services obtained from the portion of publicly provided capital goods plus the services provided by unpaid domestic labor minus the defensive social and environmental cost minus the sum of the allowances for the depletion of exhaustible resources, the overuse of renewable resources and the external cost to future generations arising from long-term environmental damages. It is important to note that for the ISEW to meet the condition of sustainability, capital stock needs to be intact. Summary: modifying national income accounting systems to promote an understanding of the links between the economy and the environment is a first step towards the integration of sustainability into performance indicators of national economics. With this in mind, here we have explored the recent advances in the development of environmentally adjusted indicators of sustainability within the general framework of the system of national income account (SNA). The idea that conventional SNA does not explicitly consider the cost of natural resource depletion and environmental degradation has been firmly established for some time. Hence, to the extent that the SNA has this well recognized shortcoming, it renders GDP to be ineffective indicators of environmental sustainability. Thus, the two major challenges facing international effort to develop a green national income accounting that is anchored within the general framework of the SNA have been: number 1, the restructuring of the SNA at a fundamental level so that it well includes the needed environmental data, and number 2, the development of valuation techniques such that the environmental data are monetized as much as possible. It was to this end in 1993, a year after Earth Summit in Rio, the SNA was revised so that for the first time it incorporated a satellite system for organizing hard data and other information pertaining to natural resources and the environment. Thank you.